Now let's apply all this sun path theory to an actual house. Let's say you have a house in Eugene, Oregon, and you know the location makes a difference. The sun angle is different in different parts of the world. So you're in Eugene, Oregon. You have this house here. You have one long wall that's pointing south, so that's good. And you're thinking about passive solar heating. So let's use our sun angle diagram to figure out the sun angles. And first we want to know what altitude, how high do the sun's rays come into the house. So here's a section through the house. There's our window on the south side. We know that in the winter time the sun's going to be at a flat angle in the sky, and in the summertime it's going to be high in the sky. Let's find out just how much it is and whether we have enough of an overhang here. Then we'll also look at what is the angle on the ground. So here we're looking down at a plan view of the house. There are the windows on the south side, and we want to know how far away from true south is the angle of the sun horizontally. So we're going to use a sun path diagram, and you have this particular sun path diagram as a handout. I gave this one to you because 44 degrees north latitude happens to be about the latitude that Eugene, Oregon sits at. So we'll use this one. Now, you'll notice there's a whole bunch of lines and a whole bunch of numbers, and we're going to go through these one at a time. The Roman numerals here are the numbers of the months. So month 6 would be June, month 7 would be July, month 12 down at the bottom would be December, and so forth. Then around the top here, around this curvy line that happens to be for month 6, around the top there are some numbers, and those represent time of day. So over here on the right side, these are hours in the morning, and over here on the left side, those are hours in the afternoon. Then these concentric circles will be where we'll find the altitude, and just a reminder, those are like these rings on this sky dome. And then the radial lines, the ones that come straight out from the center, those are where we'll find the azimuth, or the horizontal angle on the ground. Okay, let's get started. Here's our house, and let's just take this one step at a time. Let's figure out how high is the sun in the sky in December. And you'll recall each of these months is calibrated for the 21st day of the month. So this will be December 21st. And what's it doing at noon, at 12 o'clock? Okay, so December is going to be Roman numeral 12. That's going to be this ring down at the bottom. There's the ring for December. And 12 o'clock, if we're looking at these hours of the day across the top, 12 o'clock is going to be right down the middle there. So there's the month of December and 12 o'clock noon. Now, let's figure out where those two lines intersect. And I just put a big old dot right there. So that's where they intersect. Now, circles, these concentric circles, mark the altitude. So where is there a circle that goes through that big dot we just marked? Well, there it is. It doesn't fall exactly on one of these grid lines. They almost never do, but that's okay. Looks like that circle that goes through that dot is somewhere above 20 degrees. So here's the 20-degree circle. Up there is the 30-degree circle. Looks like it's just a little bit above 20 degrees. I'd say maybe a fifth of the way to 30. So, and you might think it's a little bit different. That's what I'm going to call it. So I'm going to say, all right, that circle is lying at about 22 degrees. That's the altitude of the sun in December at 12 noon. So that's the angle that the sun will be coming in through our windows. Now what is happening in June? As we know, the sun is going to be higher in the sky. How high is it? So June is going to be month 6. There's month 6 up there. All right. And 12 noon, looking at the hours of the day again, there's 12 right there in the middle. So there's our 6th month and 12 o'clock noon. And let's find where those two lines intersect, and I'm going to put a big old dot right there. And now to find the altitude, these concentric circles are for altitude, so let's find a circle that goes through that dot where they intersect, and there it is right there. So this is the, I had to put that 70 in there because we were running out of space. It's actually, the 70 is under the red dot there. So this circle is most of the way, is starting at 70, most of the way to 80. Looks like it's about 78. Let's call it 78. So that's how high the sun is in the sky in June. Now let's look down. We're up in the sky. We're looking down at our house. This is a plan view of the house. And plan views are always taken about chest high. So you picture a giant saw cut through your house, and you threw away the roof, and what's left is the wall at about 4 or 5 feet high, and you're looking down at it. And let's find out what the sun's angle is relative to south in December at 3 o'clock in the afternoon. So there's our December line again, month 12. And looking at the hours in the day, there's the 3. There's the curvy line for 3 o'clock in the afternoon. And now we'll find where those intersect, and we'll put a big old dot right there. All right. So radial lines, these straight lines going out from the center, those are for the azimuth, the angle on the ground. So there is a radial line near to that dot at 40 degrees. That dot is a little bit beyond 40 on the way to 50. I'm going to say it's maybe about 41 degrees. You might say 42, somewhere in there. I'll call it 41. So that's the angle on the ground that the sun is coming in. That's the angle away from south at 3 o'clock in the afternoon. Of course, it'll be an entirely different angle in the morning, won't it? This is 3 o'clock in the afternoon. What's it doing in June? All right, June is month 6. So there is our curve for the 6th month. And we're looking for 3 o'clock in the afternoon. So there's our line for 3 in the afternoon. And we'll find where those lines intersect and put a big dot there. And now we're looking for azimuth, the line on the ground. And those radial lines are for azimuth. So what have we got? Well, we've got one radial line at 70, and it looks like that dot is most of the way from 70 to 80. So maybe a little over half. I'm going to call it 76 degrees, and you're welcome to call it a different number. You could call it 77 or 78. I'm calling it 76. So there is the angle on the ground on June 21st at 3 o'clock in the afternoon. So what we found is that in December, the sun is low in the sky. It's at 22 degrees. And in June, it's high in the sky. It's at 78 degrees. So what does that mean for us? Well, if we're doing passive solar heating, yes, the sun will be able to get into our house through the window in the wintertime. That's what we care about when we're doing heating. And in the summer, we've put a bit of an overhang on this roof, and it looks like that overhang is going to be long enough to block the sun's rays so they won't be coming in through our window when we don't want the house to overheat. So that's good. Had we not put an overhang there, we could have used this diagram to figure out, okay, where should we put an overhang? Then looking down at the plan view and seeing what angle the sun is on the ground relative to true south. In December, well, the sun's going to get in through the windows probably just fine as long as we don't block it. We don't want stuff out here. We don't want a big wall or an evergreen tree blocking it, so we should keep that in mind. In June, this is where the sun will be in the hottest part of the day, basically. You might recall that the solar window, the part of the sky that has 80% of the sun's energy, goes from 9 in the morning, so somewhere over here, to 3 in the afternoon, so somewhere over here. And okay, after 3 o'clock, yeah, there's some sun, but this is really where you get 80% of your solar energy. So, in the summertime, you do not want to overheat your house. So what this diagram tells you is that if you're going to plant deciduous trees on the south and west side of your house, this area in here needs to have a deciduous tree so that in the summertime, when the leaves are out, it will block the sun's rays and keep you from overheating. So everywhere from here, maybe on around to the south and a little bit over to the east, that should be deciduous trees. Why deciduous? So that in December, when it's cold, there are no leaves on the trees and the sun's rays can get through. So there we've begun to design what our house can look like and what our shading devices can be like.